Right, today is 3-4 in the textbook. It starts on page 161. So to go along with what you've been learning to start chapter 3, we're looking at systems of equations. Now, in 3-1, it was systems of linear equations. In 3-2, it was systems of linear inequalities. Today, we're going to start looking at three variable systems. And so this is one, especially in Algebra 2, you start to see where some other concepts mathematically come in that you hadn't really dealt with before. And so what we're going to deal with today in three variable system is something that looks a little bit like this, where we're going to go get an answer, and it's going to make what we call an ordered triple. And so we're not just going to have x's and y's today. We're going to have x, y, and z. Okay? So what they're showing you is that if we take three planes, and that's what three variable systems give us, if we take three planes, there's one spot where all three planes can intersect, okay? So that's kind of what we're looking for today. We're looking for that point where three planes, think about like, a ceiling and a floor and then a slant wall or something like that. One spot where they intersect right here in the middle of that picture. Now on some things you can have infinitely many solutions, and three planes intersect at a line. That would be this picture right here, okay? You could obviously have the same plane. You've seen that with same line with linear equations and linear systems. And then you can have no solution where the three planes don't all intersect at a point or in the same spot. So that would be any one. You could have parallel planes. You could have two parallel planes with one intersecting, or you could have three planes intersect. They don't just all intersect each other. All right, so a little bit tricky to think about. Right there on page 161 kind of walks you through, and you're welcome to go Google it and kind of learn more about what's going on with three planes. So now what we're going to do, we're going to jump to the next page, which is page 162, all right? And we're going to go solve a three variable system, all right? So I've gone ahead and written down what's going on in example 1, and I'm going to show you how it works. Now, for this, unfortunately, the calculator is not going to help us as much because your TI-84 graphs in 2 dimensions. So when we start dealing with this third variable and add that third dimension, and a little bit tougher for your TI calculator to do that. So that's what's going on. So I'm going to just use the ordered pairs x, y, and z because that's what they have to let you know what we're looking for. We're looking for an ordered triple where these three planes intersect. So you've heard ordered pair. It's like that, but we're adding that third variable in. All right. What I like to do here, I think probably the easiest way to set this up is to do elimination. All right. And so how we're going to treat this, I'm going to label which line is what. I'm just going to call this first one plane 1, and then plane 2, and then plane 3. All right, and so what we're going to do when we do elimination, I need to pick 2 of them and eliminate a variable. You can eliminate x's, you can eliminate y's, and you can eliminate z's. So I'm going to take these first 2 just because we're going to have to do them anyways. And the reason I'm picking these first 2, when I look at stuff that can cancel out, I see a negative 2y and a positive y, and I know those don't cancel out yet, but when you learned elimination, you know, hey, I'm going to go turn this y into 2y in a second to make it cancel out. So I'm going to come down here, and I'm going to list my 2 planes out. Now, again, the reason I'm labeling them, we're going to have to go back and do something with that third plane in a second. So again, plane 1, 3x minus 2y plus 4z equals 35. Plane 2, negative 4x plus y minus 5z equals negative 36, all right? And so again, we're eliminating. I just picked the y's because I think that's easier. Here's the bottom line. You could go eliminate x's, turn that into a 12, that into a negative 12 by multiplying all the way out. You can eliminate z's. You can make that negative 20 and that positive 20 by multiplying and change, it would be fine. I think the y's are going to be a little bit easier because there's only one. So what do I need to do to make this y cancel with that? Well, I need to multiply this by 2. Now, you know in math, I can't just do it to one part of it. I have to do it to all of it. So I'm going to multiply that whole second equation by 2. Don't be confused by this 2 in front. I'm just labeling what plane we're talking about. All right, so let's go multiply by 2. So I'm going to get negative 4x times 2 is negative 8x. 2 times y is positive 2y. Remember, we're trying to eliminate the y's. That's what we want. 2 times negative 5z is negative 10z. And 2 times negative 36 is negative 72. All right, make sure my math's right. I think we're good. So kind of like we did the other day, I don't really need this anymore. I'm just going to lightly scratch it out. I am now looking at these 2 planes where I've done the elimination, and we're going to add vertically. So I'm going to do 3x minus 8x is negative 5x. My y's cancel. That's exactly what we want. And I've got positive 4z minus 10z is minus 6z. And when I do the math right here, 35 minus 72 is negative 37. If you're not good at that, do it in the calculator. Now, just so you know, when you eliminate one variable, this leaves a line. That's a two-variable system. So it's standard form. We're good. We don't have to do anything, but you just got to know that kind of what we've set up and where we started. All right. So I'm going to put a star by this. We're going to come back to that. I'm going to need that again in a second because we didn't solve for x or z yet. We're going to go solve for x or z in a little bit. All right. So now here's what we got to do. In this first part, I used equations 1 and 2. Now, I need the planes. I need to use plane 3, and I can use either one of the other ones that I've already used, but I've got to go back to the beginning. So I've definitely got to use this third one, and then I'm going to use one of the other two. So I also have to go cancel out the y's. Since that's what we picked to cancel, I've got to do that in the third plane. So I'm going to go back, and as I look at these, well, between planes 2 and 3, that's negative 3y. I can turn this into a positive 3y, which is exactly what's going to need to happen for me to eliminate that. So the two planes that I'm using, I'm going to use plane 2 again, and then I'm going to use plane 3. You have to use the one you haven't used yet, and then you can use one of the other original ones from the problem. All right, so plane 2 up here was negative 4x plus y minus 5z equals negative 36. And plane 3 is 5x minus 3y plus 3z equals 31. All right, everybody catching what's going on? I picked the second plane because I can easily go, or pretty simply go cancel out these y's in a second. We have to cancel out the y's since we did that the first time. So whatever letter you're getting rid of, you got to get rid of again. Okay, I need to turn this into positive 3y so that it cancels with that negative 3y. So what do we multiply by? I'm going to multiply this top plane by 3. Kind of distributing is what you're doing. All right, multiply it out. Negative 4x times negative 3 is 12x. All right? Everybody, oh, I'm sorry, that's positive 3. Negative 12x, my bad. That's times. Cool. Negative 4x times 3, negative 12x. Positive y times 3 is positive 3y. Negative 5z times 3 is negative 15z. All right? And negative 36 times 3, if you're not good at that, let the calculator help you, negative 108. So I'm going to kind of lightly scratch out this plane. I mean, I don't really need it. So I'm just getting, I don't want to completely mark it out for you so that you got it in your notes still. But we're not really looking at that top one anymore because I've multiplied through. All right, remember we're adding these up or subtracting them vertically. 5x and a minus 12x makes negative 7x. Look what happens to my y's. Again, we made the y's eliminate up here. I've got to make the y's eliminate here, which is exactly what we did. 3z minus 15z is minus 12z. And 31 minus 108 is negative 77. Again, let the calculator help if you need it. Okay, so now I need to look at these two steps where the stars are. So what we have now is we've eliminated the y in these planes using elimination. And so what I'm left with is x's and z's, x's and z's. This is a good thing because now you're going to set it up and do exactly what you learned to do when you started learning systems. So now I'm going to take both of these and go negative 5x minus 6z equals negative 37. And negative 7x minus 12z equals negative 77. I am now going to go do elimination here. Technically, you could still try to graph this. Go get z by itself and graph and find where they intersect, and that will tell you the x and the z. And we'll go back and find the y in a second, but let's just use elimination. We've been using elimination. I wouldn't use substitution here because none of my coefficients are 1 or negative 1. But here's what I'm seeing. Yeah, I could turn one of these x's into 35 and one into negative 35, but I'd have to multiply both of them by something. That's fine. What I'm thinking is I can turn a negative 6 into a positive 12 because then that'll cancel. So let's do that. So I'm going to multiply this top now line because it's two variables. I need to make this positive 12, so I need to multiply by negative 2. You got to catch that. Make sure your signs are right. I can't leave it negative 12. It won't cancel. All right, here we go. Multiply the negative 2 through. Negative 5x times negative 2 is, positive 10x. I can't even multiply negatives. Negative 6z times negative 2 is positive 12z. And negative 37 times negative 2 is regular old positive 74. Again, catch that positive 10x here. All right, so this top one I've kind of gotten rid of. Now let's stack them. What am I doing here? I'm eliminating the z's. So I'm going to be left with x. All right, Negative 7x and 10x makes 3x. My z's canceled, which is what we wanted. Negative 77 and 74 makes negative 3. For all that math, look how this cleans up. I get x equals negative 1. Okay, well, that's nice. There's an x. I've got to have an x, a y, and a z. And so we're going to kind of keep working back up. So I need to come back up here. Remember my original ones? I kind of marked this one out, but where the stars are, I need to plug in x and solve for z. I'm going to go back to this one. That one looks a little bit nicer to me. I don't know. It looks easier when I look at negative 5x minus 6z equals negative 37. It's a little, I guess, smaller numbers than that. All right, so here we go. So I'm looking at, again, negative 5x minus 6z equals negative 37. I pulled this one back down here. Okay? I'm going to plug in what I know. We now know that x is negative 1. So I got negative 5 times negative 1. There's some substitution. Minus 6z equals negative 37. Negative 5 times negative 1 is 5. So 5 minus 6z equals negative 37. Minus 5 from both sides. I get negative 6z equals, that's negative 42. Everybody tracking? Divide by negative 6. And I get z equals 7. Positive 7. All right. Now, I found x. I have found z. Guess what we got to do now? We're finding an ordered triple. I need x, y, and z. So I need to go back, and I need to find y. How do we do that? Go back to your very original equations. I don't care if it's 1, 2, or 3. You're going to plug in the x and the z, and you're going to solve for y. I'm just going to pick the first one because they all look about the same. They don't look super hard. So now, just kind of be thinking the process here. I found x. I found z. Now we're going to find y. So I'm pulling in the very top equation here. Just that's the one that looks okay to me. I have 3x minus 2y plus 4z equals 35. The original first plane. Let's plug in what we know. Well, I know what x is, so that's 3 times 1 minus 2. Remember, we don't know y, so I'm going to leave y alone. Plus 4 times z. Z is 7. We figured that out down here. And this all equals 35. All right, we got some PEMDASing to do. 3 times 1 is 3. Minus 2y stays there. 4 times 7 is 28. That equals 35. I'm not ready to solve for y yet. I've got to combine some like terms here. I can add that 3 and 28. So I've got negative 2y plus 31 equals 35. All right, now we're good. Now let's go solve for y. I'm adding 31, so I need to subtract it from both sides. I have negative 2y equals 4. 35 minus 31 is 4. We divide by negative 2, and we get that y equals negative 2, okay? There's our third triple. So we just found all 3 variables, and here's the answer. Write it in the right order. X, Y, Z. Negative 1 is X. Negative 2 is Y. 7 is Z. That is the ordered triple where these 3 planes intersect. That's a lot of work and a lot going on, but it's just using elimination. It's adding a little bit of rigor to some stuff that you've already seen. All right, so I'm not going to do any more of those on YouTube. I'll probably work one of these in class with you. There's a couple of things that I need to show you. There are times, if you look at example 2, where you solve and all your variables eliminate. So if you look at this example, you'll see that, hey, 0 equals 0. When that happens, okay, that was between 2 planes. You need to take one of those and the other one and see what you get. If you get 2 variables in a number, this is a line. So if everything cancels out and it's equal, and then you set up and are working the other plane, the third one that you didn't use, and you get 2 variables, then this is linear. That means infinite solutions, because that means you have a line that's intersecting or showing the intersection of those 3 planes. Now, if you jump down here to example 2b, and again, you're just kind of having to track. They're showing the work right here. And they get 0 equals 0, just like they did up here. And so you go plug in and you try to eliminate the third plane with one of your other planes, and your variables eliminate again, and it's not equal. This would be no solution. Those planes don't all intersect at either a ordered triple or at a line. So this is what happens when it's infinitely many. This is what happens when it's no solution. I'm not going to write that down on the online notes. That would be something good for you to add, to go back in and put example 2 into your notes. Let me see if I can find one more of what I'm thinking. The only other thing I can think that gets tricky, and I'm kind of skimming through and not seeing it. If you're ever doing a 3-variable system and they don't give you one of the letters, like let's say you know it's X, Y, and Z, but in one of the planes they don't give you an X, then you need to plug in 0 for that X, okay? You got to be a little bit careful. Now, we're going to get to a point where we can do these in the calculator. But right now, there's a lot of good math happening that we need to make sure that we understand. And so that's kind of where we're going to focus right now. If you have any questions, come on, get up, come see me or get me over to your desk and let's walk back through it. If you don't understand the steps, remember, you can turn on those CC or the closed captioning. You can kind of read what I'm saying and you can write out your steps as I'm doing my steps. Thank you for paying attention.